LZ. So these two cancel out. This is canceled out by the absolute value. And we get this has to be greater than or equal to h bar over 2 LZ. And you can probably guess by cyclic permutation that the following is true. And so is the following. All of these uncertainty principles are true by the generalized uncertainty principle we talked about a while ago. So that means what? These are not compatible observables. So what is? Well, conveniently, if we try to take the norm squared, what happens? Now, first of all, you might ask, why not just take the norm? Well, that's because it's the square root of Lx squared plus Ly squared plus Lz squared. And what's under this is fine, but this thing itself is the devil. It is already extremely difficult just to define the square root of this guy right over here. Now imagine how difficult it is to define anything like this, let alone something like that. So that is exactly why we do not choose this, we choose that, because this guy is a lot more convenient to define. Just this operator applied twice, this operator applied twice, this operator applied twice. Simple as that. So how does this commute? How do we know that? Well, here's what happens when we write it out with, say, Lx. This becomes Lx squared plus Ly squared plus Lz squared, and since angular momentum, like all of the operators we've looked at so far, is a linear operator, we can rewrite this as Lx squared commuted with Lx, Ly squared commuted with Lx, Lz squared commuted with Lx. And of course, this is just Lx cubed minus Lx cubed. An operator commutes with itself, which makes that 0. And these other two are a little bit more interesting. What happens with them? Well, consider that this is equal to